Dear students, welcome back to operating system video lecture session. In order to continuation to the previous bankers algorithm, in this lecture session, we will discuss about safety algorithm. So this algorithm for finding out whether a system is in safe state can be described. So let work and finish be two vectors of length m and n respectively. So initialize this work is equals to available. Work is a vector and finish is a vector. Work is equals to available. Finish of I is equals to false for I is equals to 0 to n minus 1. Second one is find such I. You have to find an I such that finish of I is equals to false and need must be less than or equals to work. If there is no such I exists, then we have to go to the step 4, right? So what is step 3? If such a kind of I exists, then work is equals to work plus allocation and finish of I is equal to true, and this will send to the step 2. Again it will check for the I value which is having finish of I is equals to false, that is it is not finished, and need is less than work. Then again it will go to step 3. Otherwise, if that such kind of I is not exist, then it will go to the step 4. Step 4, finish of I is equals to true for all I, then the system is in safe state. In this way, you can assure that your system is in safe state. So resource request algorithm for process PI. Now let us discuss about resource request algorithm. Let request I be the request vector for process Pi. If request I of j is equal to k, then process Pi wants k instances of resource types Rj. When a request for resource is made by the process Ei, then we have to follow these instructions, these steps. What are these steps? Number 1, if request of I is less than or equals to need of I, then go to step 2. Otherwise, what do you have to do? Raise an error condition since the process has exceeded its maximum claim. If request of I is less than or equals to available, go to step 3. Again, go to step 3. Otherwise, Pi must wait since resources are not available. And what is step 3? Have the system pretend to have allocated the requested resource to process Pi by modifying the state as follows. How it is going to change? Available is equals to available minus request, and allocation of I is equals to allocation plus request. Need is equals to need minus request. So when we can say that your system is in safe state, the resources are allocated to Pi, then we can say that your system is in safe state. And if Pi must wait and the old resource allocation state is restored, then we can say that system is unsafe, unsafe. So let us discuss with an example. Right. So there are 5 processes. P0 through P4. There are 5 processes, P1, P2, P3, P4, P5, and 3 resource types. 3 resource types. Then resource A is having 10 instances, resource B is having 5 instances, resource C is having 7 instances. So snapshot at time T0. At a time T0, these are the allocations, and this is max, and this is available. So available type of resources 332, and it is already allocated for P0, 0 of A type, 1 of B type, 0 of C type is allocated, and its maximum need is 753, right? So now we have to construct the need matrix. So how the need matrix is defined? Need matrix is maximum minus allocation. So here you can see this is the maximum required, and this is allocated. So 7 minus 0, 7, 5 minus 1, 4, 3 minus 0, 3. Now you can see max required minus allocated. Then this will be the resultant matrix. Now we can say that the system is in safe state since the sequence is P1, P3, P4, P2, P0. P1 is having less number of need, and then P3 is also having less number of resources needed, then P4, then P2, and then P0. So in this way, if it follows this status, then it will not leads to the deadlock.